Okay, so we have one example here. Imagine we have a pipeline with the constant diameter of the 0.3 meters, 10 through like the angle of the 60. Just like the turn like the through an angle of the 60 here. The center line of the pipeline does not have a change elevation. Okay, so it's completely like the horizontal. And the discharge through the pipeline is 0.1 cubic meters per second of water. And the pressure at the bend is 30 meters. Okay, calculate the magnitude and the direction of the resultant. So this is the way we're just going to go ahead with that one. So first of all, we need to calculate the velocity at all directions, because the velocity is not given to us. So what we can do, we can just use the continuity equation. Is the Q is equal to A1 V1 is equal to A2 V2, because the diameter is only fixed, it's not changes. So we only have one cross-sectional area, A1 and A2 is equal. Pi 0.3 squared over 4 is like the 0.071 square meters. So this is like the A1 and A2. And you can easily, we have like the discharge, flow discharge is given to us. Flow discharge is 0.1 cubic meters per second. So you can substitute on the left-hand side and right-hand side. A1 we calculate now, and V1 can be easily calculated because the diameter is the same and the flow is the same. So the velocity is the same, which is 1.41 meters per second. And also we have some other terms. If you look at the formula that we discussed here, we have some other terms here, the P1 and P2, because it says that the pressure is all over the like the pipe, the bend is like the 30 meters. So the 30 meters is the same for P1 and P2, but we need to calculate the pressure. We have the formula for the pressure. It's 30 meters of the water. So we know the formula for the pressure, rho GH. This is the rho GH. Rho is a lot of water, is 1,000. And G is a gravity acceleration 9.81 times 30 meters. And the pressure for both P1 and P2 is like the 294.3 thousand newtons per square meter. So we're just going to use the formula that we learned for the X and Y direction to calculate Fx and Fr based on what we learned from the formula here. Because it's like a horizontal, we can apply these formula. Just bear in mind, if you have any assessment, you need to just write the control volume and calculate and derive these equations. So you are not supposed to just memorize these formulas, but you can easily calculate this one when you're just going to write the equilibrium and you can write the control volume. So let's just look at here how we can just derive that one. For the X direction, we can write P1A1 minus P2A2 cosine theta minus FRX is equal to rho Q V2 cosine theta minus V1. We can substitute everything here. We have like a P1 and P2 is the same. P1 294.3 times thousands, because bear in mind, like we're just going to use a metric units all the time, times the cross-sectional area 0.071 minus 294.3 thousands times 0.071 cosine theta, which is 60 degrees, minus FRX. Sometimes you can just factor P1 and A1, you can, and you can easily calculate. If you factor this one, inside the bracket will be 1 minus cosine theta. Cosine 60 degrees is like a half. 1 minus half is half. So you can just multiply half times this kind of like the P1A1. That's as simple as that. On the right-hand side, 1,000 times flow discharge 0.1 cubic meters per second. Inside the bracket, 1.41 cosine 60. Minus 1.41. Again, you can just, because the velocity is the same, if you can just factor that one, cosine is 60 minus 1 is like the half minus 1 is like the minus half. And you can simplify this one, is equal to half 1.41 is like equal to minus 0.71 times 1,000 times 0.1. And on the left-hand side, you can just write here, and Fx, Rx, the X components of the Fr can be easily calculated, 10.52 thousand newtons. That's for the right direction, the right-hand side. We can derive or substitute the figures for the y direction, you can easily write FRY minus P2A2 sine theta is like a 294.3 thousandths times area is like a 0.071 times 60 sine 60 degrees is equal to 1000 times 0.1 times 1.41 sine 60 degrees. And if you can simplify these equation, FRY can be easily calculated 18.22 thousand newtons. Just bear in mind all the like units of FRX and Y are newtons. So we have like this section. So the last section is pretty straightforward. You can just write the resultant force is like the square root of the sum of the square elements of the forces in X and Y direction. So you can factor 10,000, 1,000 or 10 to the 3. And inside the square root, 10.52 squared plus 18.22 squared, all raised to the power 1 second. The resultant is like the 21,000 newtons. Okay, and the theta, the phi is like the arctangent of FRY over FRX. So the divisions of like these two like the values, and arctangent of that one is equal to the 60 degrees. And just bear in mind, this is 60 to horizontal. So that is the like a figure or the angle and the resultant force. So this is like the one example for the momentum equation.